Hi guys, in this presentation we shall learn more about I2C protocol. Now we'll write I2C read function. So before writing the function, understand the purpose of reading. So what is reading? Reading is nothing but we'll read the data which is on the SDA line. Okay, so how to write that function? See, while reading we have to get the data, right? So we have to return the data. So in return type we have to specify the type. Okay, see, the return type should be unsigned character. So I'll write unsigned character should be return type, and I want it to be named as I2C read. Okay, and since we are reading, we don't need to pass any parameters. Okay, see, I have to since there are 8 bits, we have to loop it 8 times. So I have to initialize a variable. Okay, so I'll use unsigned char of I as in for iteration purpose for for I, a variable inside the for loop, and there's a buffer which I'll initialize with 0. Okay, so I have to read the data bit by bit, so I need to loop it 8 times. So I'll write a for loop, okay, which starts from 0 and less than 8 plus plus. Okay, inside I have to write the logic. So what is the logic? See, we know that whenever the clock is 0, we put the data on the STA line, and when clock is 1, we take the data from the STA line. So in order to take the data from the STA line, we must allow the device to put the data on the STA line. So what I'll do is I'll make SCL as 0, which means I'm allowing the other device to put the data on the STA line. Now I'm making SCL as 1. Now I'm not allowing the device to put the data on the STA line. Now I'll take the data because SCL is 1, right? Now what I'll do is, after making SCL as 1, I'll check whether the SDA line is 1 or not. Okay, if it is 1, then somehow I'll manage to store the data in the buffer. Okay, if it is not 1, by default the value in the buffers are 0. So the logic looks like this. See, whenever the buffer is 0 initially, which means all the 8 bits are 0. All the 8 bits are 0. By default all the values are 0 here. Okay, if our data is something like 1010 1100, except these places, okay, except these places, remaining all are 0, which means I'm checking only once. If I got 1, I'll replace the 1 there. If I got 0, I'll do nothing because the default value is 0. Okay, how to write that approach? I'll use an or operator. So how exactly we use, you will see. See, this is an or logic. You can see that no matter what the data is, if I or with 0, the result is always the data. Okay, no matter what the data is, if I or with 1, the data is always 1. Okay, so we're going to use this logic. So how we can use, see, what I'll do is, this is our data, for example. Okay, I'm going to transfer. So first I'll put 1. If I put 1, then this condition is true. If this condition is true, I have to store somehow in a buffer variable as at this position as 1. So how can I do that? By suppose if I want to make the buffer 6th bit as 1 at this position, so how can I do that? See, this is the initial position. So the logic is, I'll take a number that's look like this, 10000000. Okay, now where I want to make it 1, I have to move this number to that position. So this is at 6th position, right? So I have to move to that position. So since here we can see that to move that position, I have to make the I1. Okay, so after move this in right shift by 1 time, the result something looks like 01000000. Okay, so this is the after the shifting. If I do this or operator between this number and this number, so we'll get the answer as this. Okay, so this is the logic. So how can I write that? See, initially buffer is we have taken, and we have to or with the number this hexadecimal 80, which represents this number. Okay, I have to shift I have to shift this, depends on this loop. Okay, depends on this I value. Okay, I runs from 0 to 7, which is satisfied from this. Okay, and if it is 1, which means if we want to put the data 1, then this operation will be done. Okay, if it is we want to put the data 0, there is no operation done, because by default all the values are 0. Okay, at that value, at that index, the value is skipped. Okay, and we have to store the data in the buffer. Okay, so this is how we're gonna read the data, and after reading the data we knew that we have to return the data. So I write return buffer.